And we're live again with JavaScript Air. So just like a half hour ago, I finished up this morning's bonus show about Yarn, and we're doing our very last show of JavaScript Air for now, episode 48, JavaScript in the Web Platform. We're joined by Brendan Ike, who created JavaScript, and that's pretty awesome. So we're going to be just kind of chatting about some of the cool things in that are ahead for JavaScript and the platform, and some things that are exciting about this amazing platform. So before we get into that, I just want to give a shout out to our sponsors that have made many of the awesome things about the show possible. I'm so grateful for them. That's Egghead.io, the show's premier sponsor, has a huge library of bite-sized web development training videos. Check them out for content on JavaScript, Angular, React Node, and more. Egghead.io is also the host of 2 free Redux courses from Dan Abramoff. Find them at egghead.io/Redux. And Frontend Masters is a recorded expert-led workshop with courses on advanced JavaScript, asynchronous and functional JS, as well as lots of other great courses on front-end topics. Check them out at frontendmasters.com. Also, a huge shout out to them for this new thing where all subscribers have access to all of the workshops, like the live workshops. So they're no longer tickets for the workshops, just subscribers can go, which is pretty cool. And then Track.js reports bugs in your JavaScript before customers notice them, and with their telemetry timeline. How do you like that, Tyler? Telemetry timeline?
That's a tough word. I messed that one up last episode.
No, I messed it up for like the first 3 episodes. So yeah, telemetry timeline. It's pretty awesome. You'll have the context to actually fix them. And actually, if you haven't seen the telemetry timeline, go to their website. I'm pretty sure there's a demo there. It's pretty cool. Check them out and start tracking JavaScript errors today at trackjs.com. All right, so yeah, for this show, it is the last show for the foreseeable future. If you're interested in learning why and that kind of stuff, I have a blog post. If you go to jsair.io/sunset, then that'll explain why I'm sunsetting the show. But yeah, we have this show today, and it's going to be great. If you do have questions while you're watching live, use the hashtag JSAirQuestion on Twitter, and I have that open, and I'm watching. So feel free to ask questions. We'll answer those toward the end. And yeah, still follow us on Twitter. Even though the show is sort of ending, if I do start it up again, I will start tweeting. So that'll be the best way for you to know that the show has started up again. And yeah, that's pretty much it. So let's go ahead and get an intro. We might have a panelist or two show up partway through the show, but we do have Tyler McGinnis for our panel.
Hello.
And again, I'm your host, Kent C. Dodds. And for our guest, we have Brendan Ike. So,
Hey.
so Brendan, why don't we give a quick intro to you, who you are, what you're doing, especially for people who may be new in the community who don't know who you are yet.
Hi, I'm Brendan Ike. I created JavaScript at Netscape in May 1995, and I've been working on it ever since. I also founded Mozilla.org in 1998, and we took it independent in 2003 and did Firefox. We started the browser market. We started HTML standardization with the WhatWG. We started ECMA standardization of JavaScript. And the rest is history. We kind of made the modern web happen, and I was a big part of it. And now I think it's important to keep innovating on the web and doing things that give users control of their destiny on the web. And so I'm doing a company called Brave Software. We have a browser on all mobile and desktop, laptop operating systems that blocks third-party ads and trackers and protects you and your data. And we hope that that turns into something big with your help.
Awesome. So like already so many questions that I want to ask. That last little bit you said with your help, I'm curious, can you talk a little bit more about the Brave browser, what its goals are, and how people can get involved in helping?
Yes. So I'll talk about what it is first. So Brave is not just yet another browser. It is on all the operating systems we know and love. It's based on sort of standard and as much as possible open source code. Like it's all open source on Mac OS, Windows, and Linux. And on Android, it's based on the open source Chromium project code, which you can pretty much build a browser from. So it's all open source there, as far as I know. Except for things like the video decoders and stuff like that. And on Mac OS, it's based on UI WebView, which is the old WebView, but it's the one that gives you all the control over like network request level blocking and HTTP to HTTPS rewriting, things like that. So it's open source, so that's one way people can contribute. But the really big idea with Brave is beyond just an open source browser. We've got 3 of those, maybe even 3.5, because Chakra Core in Internet Explorer and Edge is the Microsoft JavaScript engine, and it's open source now. Maybe someday they'll open source Edge. It wouldn't surprise me. And then you'd have 4 open source engines for the big browsers, and things like Servo from Mozilla coming along. What's really different about Brave is that we're trying to solve a problem that was an accident of history. When and I said this at a talk in Vienna last week, when Mark Andreessen and Eric Bina added the image element to HTML in 1993 in Mosaic before Netscape. You can find Mark's post about this. It said, hey, we wanted to add images to HTML, so we did it. The IMG element, you just can embed an image. You can link to your image even from another site. Why not, right? Everybody loves cat pictures. Your friend has cat pictures. You want to hot link them from your site. It's hot linking because if 10,000 friends do that and they all reload their page at once, your server melts down. But anyway, it seemed like a good idea at the time. So images were born, and they could be embedded in HTML, but located on a different server. Then in 1994, at Netscape, Lou Montulli created the cookie. And I think the reason he did this, I wasn't there yet, but from going there soon after I heard and saw the code, the idea was to prevent you from having to log in every time you went back or restarted your browser and you had a session with a site that knew about you that you authenticated with. Because HTTP was stateless, there was really no way for the site to remember you again. And so cookies were invented to sort of cache your authentication credentials. And it's a little bit of storage for that site in your computer, on your, on your persistent storage, your hard disk in those days. And it's sent with every request, and the server can send back an update to the cookie. So it's this little bit of state that can sort of track the site, but it's in the sense of keeping your login credentials. That tracking is good. That's keeping track of you, so you don't have to keep typing your username and password over and over, which kind of gets to be a drag. So suddenly, just between images and first-party cookies, tracking via third-party cookies was created. Because if you think about it, you can put that cat image on NewYorkTimes.com and on ESPN.com, loaded from mycattracker.com. And when you go to New York Times, if you haven't been there before, you load that cat picture, it can set a cookie. It can see that there wasn't the cookie already remembered for you, and it can say, hey, this looks like a new user. I'm going to give them number 1234. And that cookie is associated with mycattracker.com. Images get cookies. Everybody gets cookies. All requests get cookies. Now you go to ESPN.com. My cat tracker's cat image is embedded there too. It's maybe embedded with a different URL path name or query, so you can sort of tell if you're My Cat Tracker that it's embedded in ESPN and not New York Times. That's the way that the cat tracker site can tell which embedding it was answering that image request for. But now it can see, hey, there's a cookie, my third-party cookie, that has user ID 1234. So I know that user ID 1234 was at New York Times first, because I saw that request and I remembered it in my database, and I gave that user that number 1234. And now I see the ESPN URL loading that same image, and therefore the same cookie is being returned, is being sent over with the request by the browser, because it's the cookie is associated with mycattracker.org. And sure enough, tracking was invented, and this was not intended as far as I can tell. It was used right away, though, because everything on the web gets used. Every single thing. Unintended APIs, accidental serendipitous, wonderful discoveries that are useful or dangerous or both, they all get used. So third-party tracking became a thing because if you think about how advertising on the web works, publishers want to sort of know about you to get the best promotions in front of you. And publishers generally aren't the same as advertisers, marketers. I mean, Amazon is, and they know a lot about you, and they have a great site where they can market things to you based on just your behavior within that site. But a lot of publishers, just like a small blog or even a medium-sized news site, they don't know everything about you because they don't see where you go on the web. But the third-party trackers can try to get their, essentially their cat pictures. It's really not images anymore. It used to be that they would use what's called a pixel. It was a 1-by-1 image, and they would embed that, and you couldn't really see it because it was so small. And now they just use scripts. Because in 1995, I invented JavaScript. And JavaScript can be loaded remotely since 1996. And therefore, JavaScript can do things without even any pixels to track you. And that's how modern tracking works. And the point of the story is not that, tracking's all bad or all good. I think it's generally kind of bad. It's kind of shady. It wasn't intended, and therefore there's no control over it. There's no way to, as a user or a web developer, to really express it as a clearly intended thing. It just kind of falls out of the images, cookies, and scripts that we have as the basic building blocks. So there's this problem that the primitives are too low level, and they let, they're tools that allow good or bad to happen. The trackers also, could say they're doing good because they're trying to build up a better idea of who you are so that a small or medium publisher can go to what's called the buy side, the marketing side of the ad ecosystem and say, hey, I need good ads. I need to make some money so I can pay my server bills, pay my editors and writers. Can you get me good ads? And the buy side will say, here, put the script in your page, and it will help track your audience, your users. And because that script comes from a third party that's embedded in a lot of other sites, we'll know a lot about them. We'll have a dossier on them compiled from ESPN, New York Times, and all the other sites they went to. Okay, well, that helps the publisher maybe get better ads, maybe not. I mean, we've all seen how advertising tends to go in these sort of boom bust cycles where at the end of it, you have too many ads and they're bothering you, they're retargeting you, or they're showing you parasite pictures or around the web pictures, or pictures where you see something that you want to see and you click on it and you get a listicle with 20 pictures and none of them is the one you saw that you clicked on. That's annoying. And the retargeting is kind of creepy. It can like ruin your children's birthday present if you're shopping after hours when they're in bed, and then the next day you're sort of going somewhere and you get retargeted for the ad for the gift you got for them, even though you already bought it.
That happens too in the opposite way. Like some random ad will come up and my family will be like, what have you been looking at? I'm like, whoa.
Yeah, it's not very precise. The claim that the trackers can build a dossier on you, it sounds very fancy, like a spy novel. They often don't have more than a few bits to rub together. You can go to autotrader.com and suddenly you're cookied as an auto intender, and you go to any site after that and you're starting to get these like Ford ads, and it's like, am I buying a Ford? I don't think so. But worse than these annoyances and the sort of clutter that happens as the annoyances don't generate the payments, the performance, the revenue that the publisher wants, so that the temptation is to add more ads. The really big problem here is that you lose all your data to these third parties, and they take advantage of that. They do things like pairing your sort of online dossier with your offline identity. I heard about this recently. There's something called Circulate. You put it in your website. It's a third-party tracking thingy script, and it looks for email addresses in form submissions, and it hashes them, does a cryptographic hash of them, and tries to remember them. And eventually, I think it can matchmake you with real email identity. And there are similar things that will sync you with your Facebook identity, your credit card identity. So I don't know if you've had this experience. You go to a brick and mortar store, you buy something, and then you go home and you get ads for it. It's like, whoa, how did they know that? There's a little sort of credit card ad tech module at the point of sale, and it sends a signal to some server, and there's some back channel where this is all synced up. That's getting out of hand because it starts to identify you individually. So now not only are they sort of deciding that you like sports or news, they're deciding who you are down to your home address. And that can be abused not only for marketing, it can be abused by criminals and governments, and it is. So the final straw for me was when I realized that malware was getting in through what are called ad exchanges, because as this ecosystem evolved between the marketers who sort of spend money to advertise brands and consumer goods and services, things like that, and the publishers who provide the space for the ads, in between those two sides of the ecosystem, a bunch of algae and shrimp and um, all sorts of snails and other things you get taking over your aquarium, your child's aquarium, happen to come along and fill in and try to take advantage of the money flowing through. And that enabled some predators to come in. And I kid you not, this was part of my talk in Vienna, they set up fake ad agencies and they buy cheap ad space, like 40 cents per 1,000 impression ad space, which gets onto the top sites. Like the New York Times had this in March, BBC Online had this in March. And these cheap ads actually have malware payloads in them. Sometimes they're very cleverly disguised, like ad Golas, which is, I think Golas is from Dune. There was a great analysis of ad Golas malware malvertising by Proofpoint, and I used an image from that with permission in my talk, because it showed that there was the sort of publishers and their happy websites, and behind them were the ad exchanges from OpenX, AOL, Yahoo, and others. The ad exchanges are like auctions for real-time placement of ads. When somebody's got the dossier on you through third-party tracking, and the publisher has embedded their script, a call goes out to the ad exchange and says, here's the cookie, can you find me the best ad for this person at this moment in the context of this publisher site? And then the ad exchange sort of says, okay, well, I've got some ads, I got some space, can I get a deal? Do I hear 40? Do I hear 45? Do I hear 50? They try to get the best, pennies per 1,000 impression rate, or whatever the measure of performance for the ad is. And the criminal gangs are willing to throw money at this, like 40 cents per 1,000 impression, and they sometimes win that bid. And when they win that bid, the payload comes in, it looks like an ad, maybe it feels like an ad, there's nothing overtly obviously wrong with it. In the case of AdGolas, the malware loader script was, I believe, hidden using steganography, which is kind of like cryptography, but less mathematically irreversible. It's more like just hiding messages or signals inside what looks like noise. And if you know to look for it, you can see it. And so the malware loader was hidden inside the image, and a little bit of JavaScript that was probably like pretending to be gamma color correction or something would pull that malware loader out of the image after the script had loaded on your page as part of the ad. So suddenly you're on the New York Times and you're getting pwned, right? The Angler exploit kit from the New York Times incident would attack vulnerable plugins like Flash and Silverlight. And I don't know if you noticed yesterday there was bad news for Windows and Flash. Yet another, patch for a remote code execution vulnerability in Flash. If I had $1 for every one of these, I'd be a billionaire. And they're not going away. So that's what happened. Malware came into this very permissive, deep, kind of fraud-prone ecosystem. And I say fraud-prone because there's another problem besides the criminal gangs and the annoyances and the clutter and the money going out and your data getting identified down to where you live, and that's that there's fraud in the system. When I showed the picture of how the ad exchanges go provide real-time ads, try to find the best ad for the space for the publishers, I pointed out that the exchanges take a fee when the ads come in. And they take a fee whether the ad is fake or real, whether it's malware or even just a sort of an ad that is intended to get somebody to click on a fake site, a phishing site, or a clickbait site. So there's a conflict of interest. The exchange owners want those fees, and they kind of don't care if they're good or bad. So they're going to take fees whether the ads are good, bad, or dangerous. And that kind of conflict arises when you have this sort of deep layered system with too many middle players, too many agents of agents of agents in between each other, in between the principals who are the marketers and the publishers. So anyway, long story short, this was all accidental. It's kind of turned toxic and parasitic. And I think it's a concern for, citizens around the world. Citizens of the web, citizens of nations should worry about this, because there's criminality, there's fraud, there's privacy, there's sort of data exfiltration at a large scale, and it's not good for anybody except those middle players, arguably, who are taking their fees.
So Brendan, that's like a whole bunch of really cool stuff you just said. One thing you mentioned, that Flash has so many vulnerabilities that if you got $1 every time, you'd be a billionaire. So I'm curious why that is. Like, what is it about Flash that makes it so like consistently vulnerable? And is there any chance, like the web keeps adding more APIs, giving you more power as a web developer? Is there any chance that we could see our browsers being just as vulnerable and dangerous as Flash was?
I don't want to pick on Flash. Browsers have vulnerabilities. Any significant code base is going to have vulnerabilities. It's kind of a truism. It's a scientific fact, really, mathematical. I was watching a talk by Sergey Bratus, and he said this is it's a consequence of the sort of undecidability. The Turing and Church developed David Hilbert's 10th problem, which was, Hilbert said, can you make a sort of a mathematical system for solving certain kinds of equations? And this led to the general idea of, can you make a computer that can look at a program and decide whether it halts, the halting problem? And Turing proved you cannot. And this is a serious consequences, including we cannot statically analyze our code and find all the bugs. So we have to test it at runtime. Static analysis is good. It's additive and complementary. I still find like fuzz testing, where you generate travesty inputs and feed them to programs, is more productive than static analysis. But you want both. So this is kind of, when people learn this, sometimes if they are far-seeing, they realize this means security will be a job forever. It means you cannot hope for a day that comes when we suddenly fix the last remote code execution vulnerability and we're done, because living code always changes, and changing code needs testing because you cannot statically find all the bugs. So I don't want to pick on Flash too much, except now I'm going to pick on it because it really has gone sour too. And the reason is, I think Steve Jobs killed Flash, but he did it with some fist of the North Star super punch that caused Flash to become a zombie that's been lurching around eating people's brains ever since, and eating my computer's brain until I turned it off the other year. Steve Jobs, two of his greatest contributions, in my opinion, are Thoughts on Music, where he said no to DRM, and Thoughts on Flash, where he said basically Flash is like this other runtime, and we already have our own web browser. We already have Safari, WebKit. We don't need Flash, and Flash is just going to suck power and be a second-class citizen. And I think he was right. I mean, people said he was unfair, and there were things he said in the blog post that weren't true. Like he said, Flash is based on older code. It's like, wait a minute, iOS, Mac OS are based on like BSD Unix and the mock project from CMU from the early 90s or whenever. There's a lot of old code in Apple software, but the age isn't the thing. It's whether it's living code that's been brought forward. And the problem with Flash, I think it was a single vendor that had its day and did really innovate with Flash, truly innovated ahead of the web, because the web was being monopolized by Microsoft. So while we were trying to do Firefox and take back the web, and we did succeed in that, Macromedia was charging ahead with Flash, and they did a bunch of cool stuff. They even picked up a version of JavaScript that was designed on paper but never implemented outside of Microsoft's system, called JS2. This was the original ES4. It never got to the standards body because ECMA was mothballed in 2003 due to the IE sort of nuclear winter, the IE monopoly. But the Macromedia guys picked it up, and they already had a language based on JavaScript called ActionScript, 1 and 2. I think 2 added a few other things on top of 1. Might have added some kind of class, I forget. And then ActionScript 3 was the big one, where they took these ideas from Waldemar Horwat, who I gave the keys to the kingdom to when I was at Netscape, when I went to do Mozilla after I had standardized the first version of JavaScript. And Waldemar was very smart, and he said, I'm going to make a big JS2 that's going to be like the next version. It'll have classes and packages and namespaces and all sorts of stuff. Some of that we then tried to also dust off for ES4, and that's why we partnered when I was at Mozilla with Macromedia, who got bought by Adobe. So Flash had this sort of arc where it was doing well, it was innovating, and they did Flex. I don't know if you remember that. XML markup for building, apps, rich